All right, so welcome to the video lecture series on Introduction to Computer Networks. This is part 2 of our lecture on the topic of VPNs and firewalls. So we will jump to the point from where we left off and all right. So we now have a basic understanding of what VPNs are, and if you try to understand the different kinds of VPNs based on the properties, the security properties and the requirements of VPNs, they can be classified into three basic categories. The first one is what we call a remote access VPN. This is very similar to the scenario if you are using a VPN client to access, for example, a virtual machine on the campus network. So a remote access VPN allows users who are remotely located to securely connect to another remote network which is private. And this connection is actually established over a shared network infrastructure. The best example is basically the internet. So for example, if you are at home and you are trying to access the internal network of your campus, you can use the remote access VPN to establish this VPN connection. For this particular type of VPNs, we are required to we are required to set up a VPN server, which resides on the private network side, and on the host side, which is trying to connect to the private network, we are required to use a VPN client software. The VPN client establishes the tunnel between the host and the remote network, which is the private network, and then allows the remote access to be established. The next kind is called intranet VPN, or very commonly known as site-to-site VPN. And in this case, we actually have a very common example where, let's say, you have multiple locations of a corporate office, and all of these offices need to be connected over a private channel. However, they do not want to spend any extra money on leased lines, and also want to be able to connect to the outside network as well. So in that case, they can create what we call a site-to-site VPN, which allows a secure connection between remotely located network sites using the public network infrastructure. So basically, you are using the internet to connect multiple networks which are private using a VPN tunnel. The third kind is kind of like a stretch of the site-to-site VPN, and this is where we would like to provide a secure connection for special or specific clients. The best example could be particular external parties, for example, customers or suppliers or partners, and they can connect to the private corporate network using the public infrastructure, which is the internet. So in the extranet version, which is kind of like a subclass of the site-to-site, you are incorporating a bit more of control into who could connect as clients and who could connect as actually internal members. Anyone who is an internal member from another office would essentially become a part of the intranet VPN, which is a site-to-site connection. And then if you are a client or a customer, you can connect to the extranet VPN to access the private network. And if you would like to just look at a simple VPN application scenario, if we have, let's say, a head office, which is a private network, and then we have these regional offices, which are also private networks, and these networks between the head office and the regional offices, they could be connected using VPN tunnels. And given that these are continuous tunnels which are operating continuously over the internet using a secure channel, we refer to this as site-to-site VPN. On the other hand, if there are users who are remotely located, let's say they could be from their homes, or they are traveling, and they can use their client software right on their hosts and connect to the head office network through a VPN server using this remote access VPN. And something that we talked about just earlier, the extranet VPN would be a special case of the site-to-site VPN where, for example, if this is not a regional office but rather a client, and the client can have a separate channel to communicate to the head office and also to the regional office, but this would be not the same privilege that the regional office can have to access the head office network. So this client is in a separate VPN network, and this could be classified as the extranet VPN connection. All right, so firewalls. What are firewalls used for? We have seen that VPNs allow secure connections between two endpoints, but however, if we have a network set up, there are a lot of cases where people are trying to access our network. It could be our web server, our email server, etc. And in all of these cases, we would like to have some form of control in the way that people are connecting to our network. So the basic idea of a firewall is to have a control in how we can prevent unauthorized programs and hosts from accessing our private and secure network. And the way that firewalls work is that they inspect individual network packets. So each and every packet that is sent to the private network, it goes through the firewall, and the firewall then applies various policies before the packets are actually forwarded into the network or outside of the network. So it is filtered packet by packet and inspected packet by packet on a packet by packet basis. Firewalls generally are classified into two types, hardware firewalls and software firewalls. Hardware firewalls are more in the router level, right? So they are used to protect the entire network. So if I have a hardware firewall placed, installed on a router and placed at the edge of a network, so if I say this is the firewall and this is our private part and this is the public part of the network, the whole private network is actually protected from the outside world with the help of this router. These are more expensive and also complicated to manage and configure for operation. And most importantly, they are installed at the router level so that they can monitor individual packets which are coming into the network. The other kind of firewalls would be software firewalls, and they are typically used to protect individual hosts. So they're kind of like a software application which are installed on let's say your computer. And for example, most antivirus software actually do have a firewall application installed with it. For example, if you're using Windows, Windows also has a firewall along with it so that it protects the packets or software programs which are trying to access your computer over the network but are not actually authorized. They are essentially much less expensive to configure and maintain, and also pretty easy to set up. So it's just like a software, you set it up and then it starts protecting the individual hosts. So if we try to look at how how the software and the hardware firewall would protect a user. So let's say we have a user who's placed behind a firewall, and there is a software firewall installed on the user's PC. And in addition to it, there is also a hardware firewall which is installed at the edge of a network on a router. So if from the internet there is an unsecure connection trying to access the private network. Someone like an attacker trying to access the network and hack into the internal network. The hardware firewall will block the unsecure and unauthorized connection that is originating from the internet. However, let's say it is not exactly a connection that is being initiated from the internet, but rather it is a software which is now trying to get into my machine. So the hardware firewall is not able to identify that particular malware. It could be a malware, it could be a virus or whatever it is. But then when it passes the hardware firewall, the software firewall can now identify this unauthorized activity that is trying to access my PC, and then the software firewall is able to identify that particular program and then block it with the help of the software firewall. So a combination of both the software firewall and the hardware firewall is required to make sure that the user behind the private network is able to securely operate in the network. So firewalls work with the help of what we call our security policies. So firewalls, we have seen and we have already mentioned that they inspect packets during their operation, and these packets are filtered in the firewall using a set of rules. These rules, we call them policies, and they could be based on MAC addresses, which is a layer 2 address. They could be based on IP addresses, which is a layer 3 address, or it could even be based on port numbers, which is a layer 4 transport layer addressing scheme, right? So these rules can be based on MAC addresses, IP addresses, and port numbers, and also it can use individual application names and URLs as well. Which means that, for example, I can say in my security policy that do not allow any connection that is originating from a specific MAC address. Or I can say that do not allow any connection that is incoming from a specific IP address. Or do not allow any connection that is trying to connect to a particular port on my host. And alternatively, I can also say just do not allow malware X, Y, Z to access my host. And we can also apply URL-based policies that, for example, if you are working at an office, the office might have a firewall policy where the users inside the office are not allowed to access, for example, facebook.com from inside the office network. So to summarize, we can define multiple forms of these rules, which we call the security policies, and this can be based on MAC addresses, IP addresses, port numbers, applications, specific applications, or even URLs. The different approaches that we use for defining the policies, there are three basic approaches. The first one is what we call default deny, which means that you do not allow anything unless it is explicitly allowed. Another name for it is whitelisting. So we say that unless this particular application or this particular IP or this MAC or port is whitelisted, we will not allow anything. A default permit is just the other way around, which means that you will allow everything unless it is specifically blocked, which means that there is a blacklist where you say that do not allow any connections originating from a given IP address or a particular port number, but if it is not one of these, then allow pretty much everything else. The third kind is more of a controlled version, which we call limited privilege. And in this kind of policies, we say that you define the amount of access and authorization that this particular connection is allowed. And it could be the action, the reachable network or the subnetwork, or the host, etc. So you can say that if it is not a whitelisted IP, then you only allow this connection to access the web server, for example. Or you allow it to only access the VPN server, and the VPN server, if this particular user wants to authorize to the VPN server, they can go ahead and do it. So you are defining a particular action that can be allowed or not allowed with limited privilege. So if we just try to look at how these would work, so in default deny, all packets, they are stopped by the firewall unless it is an explicitly allowed packet, which will be allowed through the firewall. The default permit will allow all packets to go through the firewall unless it is explicitly restricted, in which case it will be stopped. And in the third kind, if we have a limited privilege, that means whatever packets that are incoming into the firewall will look into the packet and will define the allowed level of action that it can have. For example, this particular packet or this connection can only access the mail server or can only access the VPN server, etc. And also alternatively can say that if it is any packet that is originating from a given IP, we cannot allow it to this particular subnet, which is our most secure part of the network, and you are not allowed to access it from outside of the private network. So there are many ways that you can define our limited privilege. So you can combine these different rules to define the firewall policies and eventually be able to control what goes in and what goes out. So if you try to look at firewalls and VPNs at the same time, they are not exclusive, so they are, they can be placed with one another. So if I'm looking at a firewall, which is placed in front, well, the VPN server is in front of the firewall, this means that the private network that we have is protected by the firewall, and then outside of the firewall, we have our VPN server. So this means that if there is an external remote user, on the internet, who is an employee or, like a student, they can access or create a tunnel by accessing the VPN server from the VPN client, create the secure tunnel, and then the VPN server is what that is only allowed access to the private part of the network. So any connection that originates from the VPN server is allowed into the private network. Anything else other than this will be not allowed. So this happens when we place the VPN server in front of the firewall. In the other case, if we have the VPN server behind the firewall, well, how does this work? So in this case, if a remote client is trying to access a private or protected network, we say that the firewall will now need to allow connections that is coming into the firewall only to access the VPN server, or it can also define the web server as well. But in this particular example, we say that the firewall can only allow connections going into the VPN server originating from the internet, and then a user who is trying to connect the private network needs to access the VPN server, and then only it will be able to become a part of the private VPN network. So both of these versions are used in different setups. It just depends how you define the rules. In this case, the first case where the VPN server is in front of the firewall only allows the VPN server to have incoming connections into the private network, and nothing else that is coming in from the outside network will be allowed, right? And if the VPN server is behind the firewall, then the firewall needs to have rules so that if public connections are trying to get into the VPN server, I will allow it. Anything else, anywhere else it needs to go, I will not allow it. And only in that case, the client can have access to the server to set up the tunnel and then eventually connect to our private network. Another thing very related to firewalls is something that we call DMZ. The DMZ is short for demilitarized zone, and it is a setup that is used in standard with a combination of firewalls and multiple servers in the network. So we call a DMZ as the perimeter network or a semi-private subnet. So what is a semi-private subnet? It means that we have a part of the network which we are willing to expose to the outside world. However, we would want to still have some control. So the physical or the logical subnet where we are exposing servers, which could be, for example, the web server or email server or web proxy, etc. So we can have all of these servers placed in a semi-private subnet with certain controls being lenient, and call this a DMZ. So if we are trying to set up a DMZ, we will now have two firewalls. So the internal firewall will have very strict policies and protects the private network. So this is the private network, and the internal firewall is very strict. It does not allow anything to come in unless it is very much authorized, right? So the private part gets protected. However, there is a semi-private zone where I would want, my employees or, users to be able to access and check their emails or access my website, whatever. And they need to, however, go through the external firewall. And the external firewall has a bit more lenient policies compared to the internal firewall, and it protects the external facing servers. And the reason why we need a firewall here is to make sure that these servers are not exploited. However, they can still be accessed. The private network, we absolutely do not want it to be accessed. So therefore, the internal firewall is very strong. And then we have a part that is allowed by the external firewall into the semi-private zone, so that people who are on the internet can still access some services that we are offering in the semi-private zone. So this part is called the demilitarized zone, which is the perimeter network in most cases. And inside the perimeter network, we have our private zone that we are completely protecting it from the external access.